So let's get started. Let me take a moment to introduce you to Maxim. Maxim is going to be talking about WebDriver by BIDI, and he's going to share some insights and highlighted capabilities and advantages. Maxim is a software engineer with more than 15 years of experience, predominantly focusing on web testing. Maxim started his career in Russia and later moved to Germany to work for BigTech. He now works for Google on Chrome DevTools and web automation. His current focus is on the design and development of the innovative next-gen WebDriver BIDI protocol. So Maxim, with that, I'm going to stop my share and hand it over to you.
Sure. Thank you very much. I'm going to present. Awesome. I can see my presentation. So thanks a lot. And hello, everyone. Welcome to the presentation I prepared for you today. I'm going to talk about what WebDriver BIDI is, why do we work on it, what is the current state, and what it will probably look like. By we, I mean a cross-company working group with about 30 people working on that. So who am I? My name is Maxim. I'm a software engineer, and I started career in 2004 in Russia, and later moved to Germany to work for the BigTech company. Currently, I work for Google, and my main focus is WebDriver BIDI project. Before getting into the WebDriver BIDI, let me show how I saw the web development in pre-selenium world. This kind of mistakes, as you see in the picture, was so frequent. We needed to keep in mind all the possible scenarios and test them manually. Test it all manually. And don't forget one, it took so much time and energy, and QA team had to be super patient to work on that. And in 2011, Selenium WebDriver released. We were super excited. No need in manual testing anymore, according to my expectations. By that time, I worked for a project with about 10 engineers, and in 1 year, we wrote more than 6,000 tests compared to 500 unit tests. So it was TDD as we understood it. That is how our testing data center looked like, as you see in the picture. It was just next to my desk, and the life quality jumped significantly. We were able to test all the use cases we developed in about 2 hours. But why WebDriver is so awesome? Well, first, because it provides API to control browser, meaning lots of manual work can be automated. First of all, of course, testing. And second, it's a standard, meaning all the browser can and want to implement it, and we get cross-browser testing out of box. But it has some limitations as well. First of all, it uses HTTP, meaning all the waiting should be implemented in the pool model. Which leads to the second issue, it's quite slow. Each request establishes a new connection, and browser has to be restarted between tests to provide atomicity. Events via pool model are not that efficient as well. As soon as it's a standard, there is no quick fixes possible. And the protocol is high level, meaning no low-level control over the browser. By the way, Selenium does a great job trying to overcome this limitation. Thanks a lot. Is there any other way to automate browsers? Apparently, yes. For example, Chrome DevTools protocol, or CDP. It's a protocol allowing to control browser by Chrome DevTools. It was developed to support DevTools. It's well documented, it's open source, and it's not a W3 standard, and it will never be, meaning it's quite flexible. To give you an impression of what CDP is, let me show a quick example. If you type 21 multiplied by 2 into the DevTools console and hit enter, then what happens? A CDP message is sent to Chrome. Conceptually, it looks like this. In practice, we send a bit more parameters. The command runtime evaluate asks browser to evaluate the given script. And Chrome says, oh yeah, sure, here it is, and send us back the result. In this case, it's number, but this could be any complex JavaScript object, whatever. What's great in CDP? It's not a standard, meaning the changes can be done quickly. It's fast because we use WebSockets. And it provides a low-level control over Chrome because it is what it was developed and designed for. But there are some downsides as well. For example, it's not a standard, meaning we cannot promise it will never change. And great respect to Firefox, who implemented test-related subset of the CDP, but it's the only non-Chrome browser supporting CDP. We try not to, but sometimes we make some breaking changes. And it was developed to implement DevTools, not tests. So it's not that ergonomic in some cases. For example, working with out-of-process iframes takes lots of effort. But can CDP be used for test automation? Oh yeah. There are plenty of CDP-based testing frameworks and libraries available. For example, Puppeteer. I currently work along with the WebDriver BIDI on the Puppeteer. And what it is? It's a Node.js library, which can be used to automate browsers using CDP, but without getting into the CDP complexity. And it provides great low-level control over browsers. But it has its own limitation. First of all, it uses non-standard CDP, and it's only Chrome. It has only Chrome and Firefox supporting. Why can it be cross-browser? Because the protocol is not the standard, and we are working on it. The idea of WebDriver BIDI is to make a standard bidirectional protocol to browser testing automation. And during development, we are facing the following challenges. It cannot be a twin of CDP, only a cousin, because of the Chrome specific in CDP. It should be ergonomic for users. We don't expect developers to implement WebDriver BIDI clients themselves each time, but we don't want to make it overcomplicated neither. It should be possible to implement at all. For that, we try to process the W3C standardization because all browser vendors are involved in the specification process. It's open for participation from others in the web ecosystem, and the result is standard, meaning any vendor can implement it, and we can expect most of the vendors won't implement it. Currently, what we have the following state. This is what it is almost ready for now. You can see the concepts on the slide. And these concepts are in discussion, in active discussions right now. We have some prototypes. I'm going to show you some specific examples at the end of my presentation. But here, what we prototyped already. And we implemented some tests for the BIDI as well. Can you touch it? We have a prototype. It's written using Puppeteer on Node.js. It's really unlikely the final implementation will look like this, but it allows us to check the feasibility of the protocol to start implementing tests. Why did we choose this way? Because it's fast and easy to prototype a synchronous protocol on JavaScript. Having Puppeteer makes it even faster and easier. But dependency on the Node.js make it usable only for a prototype. We are considering ways to implement BIDI on Chrome.js engine called V8, but it's still in the very early stages. So, almost hands-on. Let's see how it hopefully will look like. First of all, I'm going to show you what we expect from BIDI. I'll make it by giving examples using Puppeteer, and then I show what we already have on BIDI. So let's get the simple scenario. Open Google, search for Chrome, and make a screenshot. It's a JavaScript, and the code is slightly simplified, but the original code is very close to what you see here. We open browser and close it at the end. Under the hood, Puppeteer launches headless Chrome instance and connects to it via CDP. Then we open a new tab. Puppeteer sends a CDP command to open new tab and waits it's open. Go to Google with a search request Chrome. In headless mode, you will not see the page like this on the screenshot, of course, but you can always run Chrome in headful mode for debugging purposes. And you verify the Google login there. And you can make a screenshot. At this point, you can see that it looks like even in headless mode. Easy peasy. But what about mobile version for Google? Can we emulate a mobile device? What does mobile device mean? It has some specific resolution. It provides touch events along with clicks, and it provides specific user agent heads. Resolution, touch events, and user agent. Let's get the very same code from the previous example and add some changes. First of all, I get pre-stored pixel phone data, which contains everything needed for emulation, and simply emulate the pixel phone. As you see, navigating to Google search results page gives mobile version. Even with the Google Play ads, it is shown because Chrome mocked user agent of Android device. Well, some more low-level control over browser. Let's emulate geolocation. You're already familiar with the code. We open a browser and open a new tab and close it after we are done. But before closing, at first we provide a geolocation permission for the page. Then specify the city. For example, Yekaterinburg, the city I grew up in, nice city, it's definitely worth to visit. And emulate the geolocation. This line makes a CDP call emulation set geolocation override. Now we open a new page and open Google Maps. Look where we are. It's Yekaterinburg. I wish to be able to travel that fast. That's quite low-level control over the browser. I already mentioned how it can be useful for the testing. But why cannot we just add a few comments to WebDriver? Why do we invent a whole new protocol? Let me give you an example of where bidirectional connection between browser and testing system gives a great advantage. Events and interceptions. For example, while working with network, we can listen to network events, mock network response, even mock APIs to test single-page applications without having the whole backend in the very specific state. And we can emulate network conditions like 3G. In this example, we are going to the Cat Lovers Facebook page. As usual, launch browser, open a new page, go to specific URL, make a screenshot, and close the browser. But I want to adjust it a bit. First, I ask browser to intercept each network request. And then I add an interceptor to each request. I check if the request type is image. And if it's not, just continue with it. But if yes, actually, I like dogs more than cats. So let's improve the page. Just replace each image with a random dog. Doggies, they're so cute. Now it's way, way better. What else it can be used for instead of playing with cats and dogs? As I mentioned before, you can mock an API for a single page application testing. You can test your UI during long network requests. You can test loading icons. You can do lots of things with that power you get with the intercepting network requests. Any other advantages of the CDP? Oh yeah, it's performance improvement. You can make accessibility testing. You can test the push notifications and even pop-up and alerts and more else. By this point, I expect you ask me, okay, that's fine, but can we use BIDI now? The answer is yes and no. We have a prototype, but it's just a beginning of a long way to specify and implement the whole new WebDriver BIDI protocol. We are about to reach the stage 1 on this picture. On the right side, you can see the progress of the specification on the left column. Prototype progress on the second from left, test on the third, and state of the web platform tests on the right. We can split BIDI protocol onto 3 major parts: its commands, its events, and its data format. This is a set of commands we're currently working on. As you see, some of them are specified, some are prototyped, and most of them are covered with tests. You can just read through the commands we have. The more or less same thing with events. And data format. I will show you what data format is. The trickiest are objects and arrays. So let's say we have an array of a number, a string, and object, and another array. How will it look like in BIDI? This is how. Each instance has a type. In this case, it's an array. And each non-primitive instance always have an object ID, which can be used to reference the instance later on as a function argument, for example. The number is serialized as a primitive, as well as the string. But the nested object looks a bit different. It doesn't have value. That's done to keep performance high. We don't want to have a huge traffic and computational overhead because of serializing all the values to the very deep. Most of use cases simply doesn't require that. If one needs it deeper, they can always make another call and get the specific object. Thanks BIDI, keep the connection open and it's fast. Another issue is circle references. The nested array doesn't have any nested value for the same reason. Basically, we use max depth equal 1 when serialize objects and keep references to the returned objects. Again, it was a bit boring, but I wanted to give you some insight on how data format look like. Let's see what we already prototyped. I'm going to open a page with a button on it, find the button, click it, and verify it is clicked. But first, we have to see what is the BIDI message look like. On the high level, all the communication in BIDI based on the messages. Messages are sent from server to client and back. Message is a JSON containing an optional ID, a mandatory method, and mandatory params field. Implementation side of the prototype is not that interesting. I'm going to show you how we test the protocol. These tests are written on Python. They're very close to what we have. They're very close to what we will have in web platform tests. I simplified the code a bit for easier reading, but again, it's very close to the original one. Almost all the communication in BIDI based on context. Each tab has a context. Basically, context is a tab. So the first line opens a new tab and gets the context. Let's not get deep into the implementation of the open new tab and navigate to HTML. It's very straightforward. The next line sends a command to open that HTML page on the given context. basically on the tab we just opened. The HTML opened has only a button. When you click on that, the console log message is sent. That's it. So now we send a command to the BIDI server. Each command needs an ID. It is used to be notified when the command is done and get the result. Then it has a method. In our case, it's a browsing context wait for selector and params with a selector, body button, and the context ID. Then wait and read the response message. Assert the response is the following. As you see, the response has the very same ID 17, so we can understand it was our command. Comments are not guaranteed to be finished in order. The comment result contains serialized node, so we get the button ID from the response. We can operate with it later on. Now we click the button. We send the message with browsing context click and object ID param equals button ID, which we just found, and wait for a message from the server. The response represents an event log entry added. You can see it in the method. And in params, there is some additional information like level info, timestamp with some value, set trace. As I mentioned, the code is a bit simplified, but it just have a set trace of the method. Its type of the event, its method itself, its context in which the event was emitted. We expect it to be on the page we opened at the very beginning. We assert it's the very same value. And it has serialized arguments. In our case, a string with a message button click. Bingo. What would happen if we pass object instead of the string in console log? It will be just another serialized object with the type object. And some values, maybe not all of them, but I already showed you how the serialization will look like. Okay, BIDI tests. Here is the list of the methods already covered with tests. Just can take a look if it's interesting. And that's actually it. I'm done with my presentation. Feel free to ask questions. Yeah.
Awesome. Thanks, Maxim. Could you stop sharing your screen for a sec?
Sure.
Awesome. Great. So yeah, we've got quite a bit of time left for questions. Just an FYI to everyone, I think we will be sharing a poll soon on the polls tab under stage. So please just take 30 seconds out of your time to answer that poll. All right, Maxim, thank you. I think I'm personally very, very excited about this. I've been following the Selenium project for many years, and my first sort of role at BrowserStack was handling our Selenium grid. So I'm very, very excited about some of the developments you've shared. Cool. So okay, I think a couple of people have asked questions about the compatibility of BIDI and on the long-term sort of vision, right? So one is, will BIDI work with all browsers, and are browser vendors working, with the BIDI sort of the BIDI spec to make sure that any of those issues are sorted?
So first question: will it be cross-browser, right?
Yes.
Currently, the working group, as I mentioned, it's about 30 people. We have people from all the major browsers. So yes, it's basically what WebDriver BIDI is just a protocol, and anyone can implement it. We have all the major browsers working on the specification, and yes, we expect every browser will just implement it later on. So in future, we expect it to be as cross-browser as WebDriver itself.
Got it. Got it. Awesome. All right. So, okay, I think a question from somebody around, someone who is new to automation. What do you recommend is a good place to start? In terms of maybe at least, it's a very, very open-ended question, I know, but like maybe a couple of resources or references or places to visit to get started.
Oh, it's a good question because I started, as I mentioned, in 2004, and I do remember the first Selenium with iframes. So it's a good question where to start with. So if person doesn't want to you can try Puppeteer, for example. As I definitely can recommend it, as I am working on the Puppeteer. The starting script is very straightforward. The installation is a couple of lines, and script itself like with few lines. So you already saw the example of how to open. So yeah, it's a good entry point.
Awesome.
There are a bunch of other frameworks, testing frameworks. So it really depends on what you need.
Got it. Got it. Okay. I think a couple of people maybe have asked this question around, if you could maybe again address specific pain points that you're trying to address with BIDI, or how is it different from anything else out there?
The first problem is, well, there are two problems. First, it's bidirectional, and second, it's cross-browser. So currently, on current technologies, choose one. We want both. We want bidirectional or cross-browser. So unfortunately, currently, like if we say Puppeteer or any other CDP-based testing libraries or frameworks, all of them uses all of CDP-based can be run only on Firefox and Chrome, unfortunately. And well, there is Playwright, which try to implement CDP testing on the Safari, but it's quite tricky there. So what we want to do, we want to make bidirectional, low-level, fast control over the browser standard. So to pick both of advantages of that two great goals.
Got it. Okay. Okay. How much faster is BIDI than the current sort of HTTP REST API architecture?
It's really too early saying about WebDriver BIDI because the only prototype we have is written on the Node.js plus Puppeteer and send the comments. So we didn't measure performance on that stack trace because it just doesn't make sense. How fast Puppeteer comparing to WebDriver? Well, there are several experiments you can search in web. Recently, I did it. I saw something about like 60%, but it really depends on lots of different things, and it depends on the experiment you make and all this. So, well, I can say it's just faster.
Got it. Okay. Got it. And how would somebody keep tabs of how BIDI is progressing and what are timelines for the implementation? As you sort of progress through your releases.
Well, we have GitHub where we work on the specification. We have updating with the current version the specification page. And that's actually the main sources of it. So you can sign up for the GitHub repository, and you can see the pull request there and ask questions and address some issues if you think we'll have some. It's always welcome.
Awesome, great. Okay. another question around the working group, right? That's working on the BIDI specification. So I think the question is specifically around Playwright, and how involved is Microsoft in the building of the spec.
Well, Microsoft is hardly involved in the specification, yes, and yeah, the department, not department, but the people who working on Edge is investing a lot of time and effort trying to implement the BIDI. So we have bi-weekly meetings and synchronize. So we actively working with them, and yeah, there is lots of effort from Microsoft applied as well.
Got it. Awesome. Great. I think, Maxim, I think we're done with questions. I'm just going through the list one more time. Just give me a second.
Well, while you're reading, just want to pay respect to that working group I mentioned, and to all the people working with us, and from Firefox, from Safari, from Microsoft, and all other people as well. So there are lots of people working on that.
Awesome. And how are the efforts looking against Safari? Because I know you're primarily working on Chromium browsers right now, right?
Well, the process of the BIDI, WebDriver BIDI development, it contains of two parts. First, it's implementation, and second, it's specification. So we are working all together from all the browsers on the specification in order to make something which can be implementable by anyone, because we can end up with some like unicorn, but no one will be able to implement it. It will be It will be absolutely useless. Yeah.
Right. Makes sense.
And yeah, and obviously it doesn't make sense to work on the Chrome for those who doesn't Chrome-based who doesn't use Chrome-based browser.
Right. Got it. Awesome, great. Thanks a lot, Maxim. I appreciate you taking the time. I think it's definitely something that I'm very excited about and keeping close watch on. I work with David Burns quite a bit from the Selenium open source project. So he keeps excitedly telling me about updates on BIDI. So great to hear from you, and thank you again for taking the time to walk us through some of the exciting stuff on BIDI. Have a great day.
Thanks a lot. It was an honor to be presented here.
Thank you.
Bye.
Bye, Maxim.